All right, guys and gals, we're going to keep talking about functions today. And today we're going to talk about this idea of slope. All right. And before we talk about slope, let's deal with kind of what that is. We said that linear functions change at a constant rate. Remember, we said that a linear function was linear. It formed that nice line. So let's draw one in here. It forms that nice line because the situation changes at a constant rate. For example, we said that, let me see if I can get this line drawn in. We said that if you worked hourly, say for McDonald's, that was a linear situation. There we go. Because you change by the same amount each time. You earn the same amount of money each hour, so it would create this nice smooth line. It's not jagged, not going up and down, or it's not a curve. It's this nice line. Now, when we're talking about a graph and we're talking about this constant rate, what we call it is slope. All right. Slope is simply how does this line go up, or in some cases, how does it go down? We represent slope as a number. All right. The further from zero our number is, the greater the slope. So, for example, as this line I draw gets steeper and steeper and steeper, the further it's getting away from zero. If we end up right at zero, then we get a nice horizontal line, right? So let's talk about all the different types of slope that are available just to give you a visual. This slope that I've drawn is an example of positive slope. And it's positive because we read our graphs from left to right. So notice this is trending upwards from left to right. We always read our graphs the same way we read in English. Here's how we find the number, right? Because all slope can be represented as a number. And again, the further that number is from zero, the steeper or the greater that slope could be. So take a look. Here's how we do it. The first step, so let's see, we'll say finding slope. All right. And here's the process. Step one, find 2 points. All right. So what I'm going to do is I'm going to pick 2 points that are on the graph here that are easy to find. So when you draw yours in your notes, make sure you put your line in the same position that I've put mine. The 2 points that I'm going to pick are right here and right here. Now, the reason I've picked these points is because they occur at nice, neat intersections. For example, I know this top point is at the point 2, 4. Or I know this point is at 0, 1. All right, I don't want to pick a point like this if I can avoid it, simply because it's not at a nice, neat spot. It's a lot harder to read and going to be a lot harder to deal with. So that's our first step, find our 2 points. All right, our second step for finding slope on a graph is to count up, or down as the case could be, from left to right. So here's what I mean by that. We're going to go from the leftmost point. So if we look at our 2 points, this is the one furthest to the left, and I'm going to count either up or down. Well, in this case, to go to the next point, I'm going to have to count up. So that's the first thing. I'm going to count up. So here we go. 1, 2, 3. Notice I can't start here and say 1. All right, I haven't been anywhere. So I have to count box to box. So 1, 2, 3. All right, and that number goes in the numerator of the fraction that we're going to write. So up 1, 2, 3. So that goes here. All right. Our third step is then count to the right. All right. So we're always working from this left to right pattern. So I counted up 1, 2, 3. Cool. Wrote that down. And now I'm going to count to the right. 1, 2. Cool. That is my slope. This slope is positive. Notice this number is positive. And I'm going to go up 3 and right 2. Sometimes that fraction is referred to as rise over run. In other words, how far up or down our rise, and then how far that we've run across the page. So we've rised 3 in this case, and we run 2 in this case. Rise over run, slope. So since this is a positive number and it's a little bit larger than 1, then it's somewhat steep. I wouldn't necessarily want to walk up that myself. If we got a slightly larger number, let's say we got 5 over 2, well, then this line would be even steeper. All right. If we had gotten 1 over 2, okay, well, then it wouldn't be as steep, right? It would have turned more like this and be a little bit less steep, all right? So that's positive slope. Let's talk about a different kind of slope. If you can have positive slope, then, as luck would have it, negative slope is possible. And negative slope occurs when our line goes down from left to right. Remember, we always read from left to right. So let's draw one in just so that you can kind of see how this works. I don't know. Let's put one of our points here at negative 2, 4. And I don't know. Let's put our other point here. We'll just make it up as we go here. There we go. Draw our line in. And again, I recommend using a straight edge. You can grab yourself a piece of paper if you don't have a ruler or protractor handy. Just take a sticky note or something. You can fold it up, or just a little scrap of paper, fold it up a couple of times there. That way it's got a little bit of thickness to it, and you can get you a straight line pretty quick that way. All right, so let's find a couple of points, and we'll show you that this slope is indeed negative. All right, the number that we'll get is a negative value. So again, we're going to pick 2 points, and again, try and pick points that are in nice, neat intersections. So this one for this linear function is here at negative 2, 4. Let's see, we had another one down here, we said, at 0, negative 1. So the first thing we're going to do is find our 2 points. We did that. Second thing we're going to do is count either up or down from left to right. Well, here's my leftmost point, so it looks like I'm going to have to count down this time. So let's get our fraction drawn. So it's going to be down 1, 2, 3, 4, 5. Cool. So down 5, because I'm going to represent that with a negative. Notice when we went up, it was positive. When we're going down, it's negative. So negative 5. So down 1, 2, 3, 4, 5. And then we'll count over. So in this case, 1, 2. Cool. So notice our value is negative in this case for our slope. So when we're talking about rise over run, this time we didn't necessarily rise upwards. We kind of sunk down by 5 and then over 2. So our slope in this case is negative. We're trending downward. So if this were a real world situation, maybe we're talking about a situation where we've got a fish tank, let's say, and we start with so much water in the tank, and then every few minutes we're losing so many gallons. So maybe we're losing 5 gallons every 2 minutes. So that's what that slope could represent. Again, just a random example there, but it works. So there are cases where we lose amounts, just like, say, in our work situation with our hourly rate that we gain. Maybe we gain $3 every 2 hours. That'd be a terrible hourly rate to work. But you understand the point. So if we can have positive slopes and negative slopes, we can also have something that we call zero slope. All right, and here's what these look like. Again, let me grab my straight edge here so it's a little easier to see. Let's pick a line here. We'll pick this one. All right, zero slope occurs when our line is horizontal. Take a look. So there's our line. Let's pick 2 points, and we'll follow the same steps for finding slope. I'm going to pick any 2 points. So I'm going to grab this one, and I don't know, grab this one. Doesn't really matter. All right. So the first thing I'm going to do after I find my 2 points is I'm going to count either up or down from left to right. Well, here's my left point. I'm going to count up or down to get to this next point. And notice I don't have to go up and I don't have to go down. I can just go straight across. So if I'm going to write my fraction, it's 0 up or down. And then in this case, I went 1, 2, 3, 4, 5 to the right. Right? Well, 0 over 5, if I punch that into a calculator, take a look, 0 over 5 is just a fancy way of talking about 0. All right. So zero slopes are situations like this where we don't really have a change, regardless of whether at 1 minute, 2 minutes, 3 minutes, let's say. Notice it stays nice and constant. This could occur in a situation, for example, maybe you are, I don't know, monitoring the temperature in a freezer, and you're looking at that temperature. And so long as the freezer's working, it's going to maintain that temperature, maybe negative 17 degrees, I don't know, but it maintains, so there is no up or down. It isn't gaining temperature, it isn't losing temperature, it's just maintaining that temperature. So that's where you might see a zero slope scenario play out. There is one other situation that we need to talk about, and this is when we have an undefined slope. So let's talk about what that means. Undefined. Now, this is a vertical line. All right, and let's be clear, vertical lines are not functions, but occasionally we will run into this situation and we just need to know it for what it is. So let me grab my straight edge here. I do not want to try to freehand this. Let's grab that one. We'll just use this line right here, draw it in. Here we go. Nice and straight. Notice, in this case, my line runs up and down. It's on the vertical. So if we were to calculate slope, again, we need 2 points, so let's grab 2 points. So maybe we grab this one and this one. I don't know, any 2 points work. Let's count the rise of the run. All right, so leftmost point. Well, I'm kind of running into problems here with the leftmost point because they're both equally far to the left. So let's just grab this one. If I'm going to count down, 1, 2, 3, 4, 5. Cool. So if I wrote that out, that's a -5 over. And then I've got to count how far to the right. Well, notice if I count down 1, 2, 3, 4, 5, I don't have to go to the right. So 0. So let's type that into our calculator and see what we get. So -5 over 0. Divide by 0 error. Here's the deal. You cannot divide by 0. In math, it doesn't work. Our result then is not a number. All right, what we say in math is that our value is undefined. I don't know if this slope is positive, going up infinitely, or if it's a negative slope, going down infinitely. We just don't know. And in the real world, we don't really see this kind of slope occur a lot of the time. But if you do run into the situation, you know what to call it. That if we see something running up and down vertical like this, we call it an undefined slope. Test writers, like in K-Prep, SAT, ACT, they'll use this a lot to try to mess you guys up. So again, be aware, 0 slope means horizontal. Undefined is not the same as 0 slope. It's a vertical line. So when you see that, you know what it is. Let's look at graphs that actually deal with real world situations so we can talk about that. These are just sort of general graphs that I showed you. So let's look at a real world situation. Okay? Take a look. This is a graph of I've got distance traveled over time. So maybe it's a road trip or something. So the first thing I need to do is find 2 points. So let's do that. So I need to find 2 points that are easy to read. I'm going to grab this one. It looks pretty easy to read at 1, 280. And then I need a second point. So I'm going to grab this point here at 2, 350. So the first thing we're told to do is to count up or down. Well, the one thing I noticed with this graph is that it doesn't count upwards, 1, 2, 3, 4 like we did here. It looks like it's counting up 70 every time. Notice we go 70, 140, 210, and so on. So it's going up 70 every go around. So when I go from here up to here, that's actually a distance of 70 units, 280 to 350. So when I write my fraction out, that's 70 upwards. All right. Now let's count to the right. If I count to the right, I notice that my axis down here is counting 1, 2, 3, and so on. So over 70, or excuse me, up 70, and then over 1. And notice that 70 represents distance, so 70 miles. And then over 1 in this case represents hours, so 1 hour. So in this case, my slope represents 70 miles per hour. In other words, this is the speed of the car. Every hour, we're gaining 70 miles, so the car is traveling 70 miles per hour. All right, let's take a look at another one. Now, for this one, for some reason, my title didn't change like I wanted it to. It kept the old title. In this case, I was looking at a fish tank. And here's what we did. We know that the tank originally held 200 gallons worth of water. And then basically we took the plug out. It had a plug at the bottom and we just pulled that plug out. And then we monitored how much water was in it over time. All right. So I've got 0 to 10 minutes to 20 minutes, 30 minutes, and so on. And then we've got how many gallons are in the tank. So notice this time our gallons side here goes up by 40 every go, 40, 80, 120, 160, and so on. Here our time, as we said, goes up by 10-minute increments. Let's pick 2 points that are easy to read. All right, so let's start there. So if we're going to find the slope, by the way, it's going to be a negative slope, right? Notice how it's trending down, so make sure your number's negative. So let's see, I need 2 points. Let's see, this point looks good. At 0 minutes, we had 200 gallons in the tank because we hadn't pulled the plug yet. And then here we are at 20 minutes. It looks like we had 160. All right, so let's count. Remember, we always start with the leftmost side and go right. So in this case, when I'm counting down, it's not one box down, it's from 200 to 160, so that's 40. All right, so let's draw our fraction. And notice it's going down, so it's a negative 40. We lost 40 gallons in the tank. And that makes sense, right? We pulled the plug on the fish tank, water's coming out. Hopefully it took the fish out first. Now, when I count these boxes, I'm not going to count 1, 2, because notice the boxes aren't counting by 1, 2. They're counting by 10, 20. So when I count this time, it's 10 minutes and then 20 minutes. All right, so we went 20 minutes. So again, 40 gallons for 20 minutes. All right, we could rewrite that. 40 divided by 20 is 2. So negative 2 gallons per minute. So in other words, after we pulled the plug on this fish tank, we lost 2 gallons every minute. So notice in the real world, our slope, as we're calling it, all right, our constant rate of change, has a meaning, right? It could be a speed. It could be the rate at which we're losing water. It's not just some random number like we see. So we need to keep that in mind. Our rates have real world implications and they're important. So we need to make certain that we know what we're measuring. Is it miles per hour? Is it gallons per minute? We just need to be aware of that. If we're given just some random graph, well, then fine. We can represent it as a fraction, 3 over 2, and we're good. But again, always simplify. So 3 over 2, it is simplified. We don't have to worry about it. But like negative 40 over 20, that wasn't simplified. So I went ahead and did the division. So we can write fractions, or slope rather, as a couple things. We can write it as fractions, right? Like negative 5 over 2. Or we can write it as a whole number, like negative 2. What we can't do and what we want to try to steer away from is writing it as a mixed number. So for example, here, I don't want to rewrite this as 1 and 1/2. I'm going to keep it as 3/2. This is one time where improper fractions are okay. All right, so we can do this with graphs pretty easy. Let me show you another thing we can do. We can also find slope from a table, all right? And I'm going to show you kind of a different way of finding slope, all right? It's a formula, and this is going to help you a little bit. It's not going to be as time-consuming as counting. Notice this counting method works, but it does take time. Let me show you a different way. When we're finding slope in a table, here's what slope's going to be. Slope, I'm going to represent it as the variable m. M is in mother. I don't know why it's done this way, but it is. So slope is equal to m. All right. So m equals, all right, write this down. Slope equals, on the top of this fraction I'm going to write, it equals y2 minus y1, all right, over x2 minus x1. All right, and here's what that means. These x's and y's represent coordinates, all right, points. Notice I've got x and y, and I could graph those on a coordinate grid, right? I could graph a point at -6, -2, or -3, -1, and so on. What these mean is they're simply coordinates, all right? I've got my first coordinate. I've got my second coordinate. Right? And what I do is I take the y's and subtract them, so the y2 subtract the y1, and then I take the x coordinates and subtract them, so x2 subtract x1. And what that does is it lets me find the slope. You can use this method with your graphs as well, but we're going to use it with tables for the time being. So let me show you how it works. Let's first, if I can keep my pins in order, let's look at this one. Again, you need 2 points, just like we did before. So pick any 2 points. I'm going to pick this one, and I'm going to pick this one. All right, so point 1 and point 2. All right, first step. The second step is we need to figure out what are the x's and y's. So notice these are already labeled for us. Here are our x's, here are our y's. I'm going to take these numbers and plug them into the formula. So the first thing the formula asks is y2. So here are my y's. Here's my second point, so I want the -1. So I'm going to write that in. -1. Subtract. Now I need y1. All right, well, here's my y's. Here's the first coordinate, so y1 is -2. All right, we'll fix that in a minute. All right, let's do x's. I need x2. All right, so here's the x's. Second point, so -3. Subtract. All right, now I need x1. So there's x1. All right, so it's a -6. Now, before we continue, remember what I told you earlier in the year. Anytime that we have subtracting a negative, we need to rewrite that. We're going to add a line and change the sign. All right? Subtracting a negative. Don't do that. Add a line, change the sign. Trust me, it makes life easier. So now I've got -1 added to 2 and -3 added to 6. Much easier to work with. So -1 added to 2 is 1. -3 added to 6 is 3. So this slope is a positive slope. It's going up 1 and then right 3. Up 1. So again, rise over run, up 1 over 3. So if we were to graph this, okay, it would look something like this, where we go up 1 and then over 3. Up 1 over 3. All right, so we can graph these if needs be, but this is another way of finding slope without having to graph and then do all that counting. So it's a little bit quicker. All right, let's try another one. So this was a positive slope. Let's try this one. Let's see what we get here. I need 2 points. Trying to get it there so you can see the formula. So again, you can pick any 2 points you want. So just to prove that it doesn't matter, I'm going to let this be 0.1 and this be 0.2. All right, it doesn't matter, just so long as you pick them and stay with them. All right, so the first thing I need is y2. So y2, all right, that's 6. Let's write that down. I'm going to do it up here. 6 subtract. Now I need y1. So y1 is 12. All right, and we'll fix that here in just a second. Next, I need x2. So here's x2. So that's a 3. Subtract x1. So there's x from my first coordinate. All right, 6 equals. Now, again, we've got subtraction. I told you early in the year, change those out. Trust me, it's going to make your life easier. So add a line, change the sign, add a line, change the sign. So here we go. I've got 6 added to negative 12 and 3 added to negative 6. This is going to make things much, much easier to do. 6 added to negative 12 is negative 6. 3 added to negative 6 is negative 3. Well, notice that fraction is something I can simplify, negative 6 over negative 3. And again, if you're not sure how to do that, again, a calculator can do that. Negative 6, ABC, that's our fraction button, over negative 3, and it'll take it and simplify it for me. Oh, well, I guess maybe it won't. Maybe it doesn't like negatives. We'll do it this way. Negative 6 divided by negative 3. We'll just play ball that way. Cool, 2. So that means we've got a nice whole number of 2. So it started looking like, well, maybe we're going to have a negative slope here. But remember, negative divided by negative is positive. So if I were to graph this particular equation, it would have looked something like this, where we go up 2 and then right 1. Because again, remember, we can write 2 as a fraction, 2 over 1. So rise over run, up 2, right 1, up 2, right 1, up 2, right 1. All right, so if we were to count it, we could count it that way. But notice our formula gets us there a little bit quicker. Right? Let's try another one. All right? Let's try this one here. Again, you can pick any 2 points that you want, but notice, sometimes dealing with negatives isn't a lot of fun, so maybe you avoid those points. Sometimes you could end up with decimals, and again, I would recommend that you avoid those. So let's pick numbers that are easy to work with. I know that 2 and 4 are pretty easy to work with, so I'm going to let that be my coordinate 1. And I know that 10 and 8 are also pretty easy to work with, so I'm going to pick that one as well. So I'll let that be coordinate 2. And remember, it doesn't matter which coordinate you make coordinate 1 or coordinate 2, just so long as you make a decision and stick with that decision. All right, you don't want to be switching things out as you go. All right, so let's look at our formula, just so we can keep it in mind. So we're going to start off with y2. So y2 is 8. So 8 subtract y1. So y1 is 4. All right. Now I need x2, so x2 is 10. Subtract x1, and that's 2. Now notice, by picking these points, I didn't have to deal with any negative issues. I didn't have to deal with any decimal issues. And this subtraction is very simple. So pick points that are easy to work with. Notice in this case, we didn't do that. We could have just as easily picked these points. They would have been much easier to work with than negatives. So again, be selective, pick points that are easy to work with. So 8 subtract 4 is 4. 10 subtract 2 is 8. I can simplify 4 over 8 to 1 over 2. So again, if I were to graph this, this is also a positive slope. It would look something like, I don't know, let's see here. I'm trying to make sure I get my points in the right spots here. It looks something like, I don't know, something like this. And it's up 1 and then over 2, up 1, over 2, up 1, over 2, and so on. So this slope, notice, isn't as steep as some of these others. A little bit steeper, perhaps, say, than 1/3, but not near as steep as, say, 2. All right, notice the difference in the steepness there. All right, let's look at these. These are real-world examples, and these should be somewhat familiar. This is the exact data that I pulled from these. All right, this is the table that I use to make these graphs. Right? So again, you can pick any 2 points that you want. Again, I'm going to pick this point because 0 is easy to work with, so I'll let that be 0.1. And then all the rest of these numbers are pretty simple, so I'm going to let, I don't know, let's pick this one to be 0.2. All right, so let's see if you can remember. Now, time. Let's talk about independent and dependent real quick. Remember, time is almost always an x variable issue, almost always independent. So this is our x's, which makes distance our dependent. How much time I'm spending on the road will determine how far I've traveled, not necessarily the other way around. So X's and Y's. So y2 is 350. Subtract y1, so 210. X2 happens to be 2. And x1 is 0. All right? 350 subtract 210 is 140. 2 subtract 0 is 2. 140 subtract, or excuse me, not subtract 2. 140 divided by 2. What do you know? 70. That's the exact same answer we came up with here. Notice, instead of having to count, we could do a real quick calculation and get to the exact same answer. And notice, it's still 140 miles over 2 hours. So we would read this as 70 miles per hour. All right, so this has actual meaning. This 1/3, no real meaning. I don't know what X's and Y's mean. So I don't know that it's one person for every 3 chairs or something. I don't know. We don't know what the rate means, but here we do. We know that Y is distance and that X is time. So 70 miles per hour. All right, take a look. Here's our fish tank scenario. Again, pick any 2 points you want. So let's change something up here. I'm going to let this be 0.2, and I'm going to let maybe this one be 0.1. Again, just to show you, it doesn't matter which ones we pick, just so long as we make a choice. So 200 would go first, because remember, time is almost always X. In this case, gallons that are left would be Y. So Y2, 200, subtract Y1, so 140, over X2, so that's a 0 this time, subtract 30. And again, I'm going to change this up, add a line, change a sign, just to make things easier on myself. 200 subtract 140 is, what is that, 60? Awesome. And then zeros added to negative 30 is just negative 30. All right. I can simplify that. 60 divided by negative 30 is negative 2. That looks familiar because this data is what let me have this graph. So I should get the exact same slope. And remember, we're talking about gallons per minute. Remember, that was 60 gallons for every 30 minutes. So we're going to lose 2 gallons every 1, so per minute, all right? 2 gallons every minute, exact same slope as what we got here. So let's review real fast because this video is going a little long. When we're finding slope, we have 2 ways to do it, all right? One way is to look at a graph, okay? Pick 2 points, count up or down, always from left to right, and then count however far to the right and write that fraction out. The other way, which also works for both tables and for graphs, is to pick 2 points and use this formula, and we can come up with our slopes pretty quickly. Today, your work will focus on this, so if you have questions, concerns, please ask. Make sure you've watched the video prior to coming to class, otherwise you will be lost. But again, make sure, guys, that you are bringing your questions with you. I want to do all I can to help. All right, have a good day, and we'll see you then.